Now that you have a basic understanding of how color works and the terms we use to describe color, we're going to look at how color behaves and mixes to create a range of different hues. Think back to when you were a child. Did you ever get to color with paints? In school, we were taught that by mixing different color paints together, you can get other colors. Mix red and yellow to get orange. Mix blue and yellow to get green. Mix red and blue to get purple. And then mix them all together to get some sort of muddy color that resembles maybe a brown. Though this is a great way to think about the way mixing color works, it is not how it operates when we begin talking about digital design or design for print media. You know by now that the light that comes from the sun contains all of the wavelengths for color, and we see color when that light absorbs into an object and bounces certain wavelengths back to us. Though we see a full spectrum of color from red, orange, and yellow to green, blue, and violet, our eyes and our brains actually process this information a little differently. The eye is made up of 3 distinct cones that process short, medium, and long wavelengths to formulate the colors we see. Without going into too much information on this process specifically, keep in mind that a red, green, blue, or RGB color model was created to hack the way that we typically see color. By using these 3 colors, we are able to fool the brain into seeing all of the colors that we would like. So how does this work? Lights of these 3 colors can be mixed together to produce all of the variations of color. Though the sun is the brightest light in our solar system, we can also use other lights like flashlights or LEDs to produce colored light. In the following example, think of the colors being used as beams of colored light. Let's start with the blue light. That colored blue light is shown here. All other colors are being absorbed, and the blue light is reflecting back into your eye and is being stimulated by the cone to produce color information in your brain. Also, remember that wherever you see black, that is the absence of color, not a color itself, even though we call it black to give it a label. Now let's add a red light. Again, that red light is just the color wavelengths that your eye is picking up. What happens when we mix these two? As you can see, the blue and the red lights combine to create a magenta color. Your brain is interpreting these blue and red wavelengths to fill in the information and actually create this third color. These colored lights are able to fool the brain into thinking it's seeing a magenta color because of the cones in your eyes reacting to the blue and red. This becomes apparent when multiple lights of red and blue dots are laid side by side. There is no magenta color, and these colors are not overlaid over one another. Yet we see magenta when we zoom out because of the way that our eyes and our brain are behaving. This is exactly how computer screens work. Though you see a bunch of colors on your computer screen, it's really only made up of red, blue, and green lights. Don't believe me? Take a magnifying glass and hold it up to your monitor. Pretty wild, right? Let's take a look at the other colors used in this RGB model. We know that blue and red create magenta. If we add green, you can see that green and blue make cyan. And red and green actually make yellow. By adding different levels of red, green, and blue, you can recreate every color in the color spectrum, and here we have a complete RGB color wheel with its corresponding colors. Since we are talking about light, you also know that wherever there is no color being reflected, we get black, and wherever all of the colors mix and reflect together, we get white. This is called an additive color system because the colors are based on lights being added together to create all of the colors. Additive color is great for anything that uses light, such as computer monitors, tablets, televisions, LED panels, and so on. Understanding the RGB and additive color models will help you when selecting and modifying colors because now you know exactly how it's working. So what about things that don't use light, like printed media? Well, have you ever changed out the ink of a printer before? Notice that it's not using the red, green, blue system. It's using the opposite colors of cyan, magenta, and yellow, or CMY. That is because this is what is called a subtractive color system. The subtractive color system works by colors being absorbed into the object or substrate. To make it easy, let's use the example of a printer printing on a white piece of paper. When the cyan cartridge lays pigment onto the paper, the red color is being absorbed, and the blue and green colors are being reflected. The blue and the green colors mix, and in our eyes, we see a cyan color. Because of the subtraction of the red color, we get the name of the subtractive color model. If you look at the colors across from the CMY colors on the color wheel, you can easily make out what colors are being absorbed. Magenta reflects red and blue, so green is absorbed. Yellow reflects red and green, so blue is absorbed. So what about the other colors? By mixing cyan, magenta, and yellow, you can make all of the other colors absorb and reflect back just the colors you would like. You know that cyan absorbs red and magenta absorbs green. By laying cyan and magenta together, red and green are absorbed, and so blue is the only color reflected back. That means that magenta and yellow will absorb green and blue, reflecting red. And cyan and yellow will absorb red and blue, reflecting green. By mixing these subtractive colors together, you can get the full spectrum of all available colors. However, mixing all of the colors do not produce a good looking black, as mixing colors of like makes a nice looking white. Instead, you get a muddy color when mixing these pigments. To compensate for that, a fourth color black is added to darken and tone the image. This is where you often hear of CMYK, and the K stands for key, or the black pigment. Once you understand the way that these two color models work, the additive and subtractive color models, you can begin using them to your advantage.